If there is one thing I've learned from backend engineering, it's that the job isn't just building APIs and returning JSON. The real work happens in the invisible systems that keep the internet running. So today we are breaking down 10 essential concepts that bridge the gap between a junior coder and a systems architect. First, authentication versus authorization. Authentication is identity, proving who you are. Authorization is permission determining what you are allowed to do. Logging in is authentication. Being allowed to delete a database is authorization. You must separate these clearly to avoid critical security holes. Next is rate limiting. Without this shield, any bot could hammer your server with thousands of requests per second and crash the system. Rate limiting caps the number of requests a user can make, preventing abuse and ensuring your resources are shared fairly. Then we have database indexes. Think of an index like the contents page of a book. It allows the database to jump directly to the data you need rather than scanning every single row. Without indexes, queries are slow. With them, they are instant. The trade-off is that writing data becomes slightly slower, as the index must be updated too. Staying on data, we have ACID transactions. This is the safety net. If you are moving money, you need the withdrawal and the deposit to succeed together, or fail together. ACID guarantees that if the server crashes mid-operation, the data is not corrupted. It is all or nothing. For pure speed, we have caching. Database calls are expensive. Instead of recalculating the same result every time, store it in a fast in-memory layer like Redis. The next user gets the data instantly, reducing database load and making the app feel responsive. But what about heavy tasks? That is where message queues come in. You cannot let a user wait 10 seconds for a video to process. Instead, you push the job into a queue, and a background worker handles it asynchronously. This keeps your interface snappy while the heavy lifting happens in the background. As you scale, you need load balancing. This acts as a traffic controller, distributing users across multiple servers so no single machine is overwhelmed. It creates redundancy. If one server fails, traffic is automatically rerouted to the healthy ones. Then the reality check, the cap theorem. In distributed systems, you can only guarantee 2 out of 3 things: consistency, availability, or partition tolerance. Since networks do fail, you have to choose. Do you want the system to stay online? Or do you want the data to be perfectly accurate during a crash? You cannot have both. We also have reverse proxies like Nginx. These sit between the internet and your code, handling security, encryption, and routing. They protect your origin servers and make deployments cleaner. Finally, CDNs. Do not serve large files from your main server. A CDN replicates your assets to data centers across the globe. Users download files from the location physically closest to them, drastically reducing latency. These are the pillars of backend engineering. If you found this valuable, leave a like and subscribe. This is Sweet Codes.